Next up, though, is a live interview with researchers working on conversational agents. One of the areas in which Microsoft Research is a pioneer. I'm having a conversation today with Lucy Vanderwende. I hopefully said that right. Bill Dolan of Microsoft, and of course Alan Ritter of The Ohio State. I added the V in there for you, Al.
Thank you.
Assistant professor from the Ohio State University. They're going to talk to us today about, well, talking. They did a lot of research in conversational systems. Welcome, Lucy, Bill, and Alan. How are you doing?
Doing well, thank you.
Fantastic. So what are some of the interesting things happening in conversational agents? Anybody can take that one.
Well, in the past, in NLP, what we used to do is build models that really involve a lot of hand coding to try to decide how to respond to a given input. Okay. And in the last several years, the field has been overtaken by newer data-driven techniques that allow us to train models on huge volumes of naturally occurring data, specifically from social media, where we can find, for the first time, we can really get access to enormous volumes of text involving people having a back and forth conversation.
Now, I remember the first conversational agent I ever wrote was the typical Eliza, you know? This isn't that anymore, right? What's the difference between Eliza and the stuff that we're working on here? Why don't you take that out?
Yeah, so I think Eliza is doing something pretty interesting, but it's like how it's actually built is really simple. It's just a very small set of regular expressions or handwritten rules. Whereas here, we're really trying to learn how to build conversational agents just from lots of data. So learning them using techniques from statistical machine translation, for example.
Okay, so statistical machine translation was something that I got to work on a little bit. I'm not understanding the link between machine translation and a conversational agent. Why don't you take that one?
So think of it as there's the language of the person who's doing the speaking and the language of the person who's doing the hearing. So, for example, you say, I'm going to Las Vegas tonight. I'm going to say, have a nice flight, right? It's a kind of a translation. You say one thing, and I'm quite conditioned to say, you know, one of a couple of things, or, you know, what are you going to do there? So it's kind of an input and an output. The difference between conversation and machine translation is that in machine translation, the content is all given to you, and you just have to faithfully do the translation. With conversation generation, you're also kind of deciding what to talk about. That's a bit of a difference, right? There's some content selection going on there.
So how, like when I'm thinking of machine learning, I'm thinking of there's a target output, or I'm looking for a specific task that I'm solving. When I talk about conversation in generalities, I'm having a hard time nailing down the task, and when I can't do that, the computer has a hard time. So Bill, what is it, what's the task?
No, that's, I mean, your background in machine translation shows, because that is exactly one of the challenges that we faced with this work, that, as Lucy was saying, in translation, the semantics of the input defines the semantics of the output. You're trying to affect the form, but the semantics needs to remain constant across that transition. In this conversational space, you're right, it's a wide open field potentially. You can respond in any way to what I might say to you. But we are taking advantage of the fact that there, as Lucy was saying, there's a huge amount of predictability in our responses. Not so much in what we say, but how we say it. So for example, if you ask me a yes or no question, there's a lot that's going to be predictable about the form of that response.
Sure.
If, as Lucy was saying, there's a lot of sort of polite conversation, chit-chat back and forth, that is highly predictable. If I say, you know, as Lucy was saying, if I say I'm going to the airport, you're likely to say have a nice flight, or where are you going, or are you going on vacation, something like that. And what we have done in translation, there's a metric that has been very powerful in helping decide whether a change you've made to the algorithm was good or not, BLEU, which is an automated metric trained on data. And we've adapted BLEU in this conversational space to allow ourselves to in an automated way, decide probably whether that change we just made to the algorithm was good or not.
And you said it's called BLEU?
The BLEU in translation is the algorithm.
So
is the evaluation metric.
So maybe I'm a little old, or I don't remember BLEU, but can you talk a little bit about what that metric is and how it actually applies? Because again, I'm having a hard time.
Sure.
I know you mentioned it. I'm having a hard time matching the two. Why don't you take that?
Sure, yeah. So Blue is like an automatic evaluation metric. So one way you could evaluate translations is to have people look at a translation, like an expert translator, and say, is this a good translation, right? Whereas Blue will actually compare the translation against a reference translation and try to determine whether it's correct, right? Because there's a lot of different ways you could translate a sentence.
By reference, that means a human-generated translation.
Yeah.
And by the time you take a sentence in English and translate it 10 times into Japanese, 10 different people translate that into Japanese, you've begun to cover the space of plausible translations into Japanese. And now you can look for n-gram overlaps, so word sequence overlaps between the way your system translates that input sentence and the way humans do. And we've done something very similar in this conversational space, looking again on social media for inputs that have across this huge body of text, of data, many different responses produced by many different people. So we can do something very similar. Given this input, we predict the response is this. Now compare sequences of words in that predicted response to what we found across the corpus for what people actually said when I'm going to the airport was uttered as the input. And so again, the space of possible responses is infinite, but you can begin to cover it in this way if you have enough data.
Yeah, I think in conversation, the space of outputs is much larger than translation, right? So in translation, the input and output are semantically equivalent to each other. Of course, so it's kind of a more constrained problem than
but it's not totally infinite, right? Because conversation, like successful conversation, runs along their cooperative principles, and I'm not going to be redundant. So if you ask me a question, like Eliza pretty much worked because Eliza asked the question, you are compelled to answer, right? So you are getting tricked into, not tricked,
falling into the rut.
But you fall into the rut. That's what we, as cooperative people in a conversation, do. And so to be cooperative also, when you ask me if you say something, I'm not going to say, oh yeah, my hairpin is blue, because it's a total non sequitur. So the space of things that are relevant to say in a conversation is not infinite. It's not deterministic. I can say a couple of things. I have some flexibility, but I'm not going to totally go off the rails either.
Right.
So, and that's what we do as people. You know, you have, when you say something, you kind of predict what I might say, what I might start talking about, but the thing that makes it interesting is when we slightly veer off topic, when I introduce a new theme, and that makes conversation engaging.
So, my challenge that I'm having, right, is when I'm doing translation, there is a specific output. And you mentioned 9 reference translations, right? But when we're looking at conversational topics, like I've had my 4-year-old come out of left field and say something.
Yeah, I mean, let me just interrupt because I completely agree with everything you're saying, and I also did not think this approach was going to work. But Michel Galli, who's in the group, a researcher in the group, is a machine translation person. He was completely convinced that this same kind of automated metric would work in this space. And to my surprise, it does, because so much of the response is predictable, even if the specific content is not. If you say, are you going? The response is very likely to be, yes, I am, no, I'm not, something or other. And just that, yes, I am, no, I'm not, is enough to give us some signal as to whether we're probably doing something reasonable with this algorithm or not. And it's really critical to have an automated metric like this because it's the combination, I would say, and then you want to correct me if you disagree, but I think translation really began to leap forward in quality
no question.
when you got the confluence of a lot of data, a lot of parallel data, that automated metric, and better machines. I think that troika allowed the field to leap forward because without that automated metric, Blue, in the old days, you had to wait for people to manually score your translations. It would take a lot of money and a lot of time to decide whether that tweak you made yesterday was a good thing. But once you could hit a button and get an instant read on whether you made probably an improvement or not, things really began to accelerate. And in this conversational space, again, that evaluation, finding an automated evaluation metric is a critical component to really making progress in this machine learning area.
So when I started machine translation, we did this thing called a noisy channel model. Is it the same thing? Because I don't know what state of the art is in machine translation anymore.
Yeah, so when we first started doing this, when I was first doing an internship at MSR, and
so you were actually at Microsoft as an intern.
Yes,
that's
right.
awesome.
Yeah,
that's awesome. So tell us about that.
This was like 2010, and this was really the first attempt in the field to build a data-driven.
That's exactly when I finished
model
grad
like this.
school. Was in when two,
Right.
no, that's
Right.
actually I had two. I was in until 2012, so that was right around the time that I was doing.
Yeah, this was really what Alan did. Was really the first attempt to take parallel data in the form of input, response, and learn a translation model from it that's going to predict the response. Anyway.
So tell us more about that. Yeah.
Yeah, so I mean, I think I was just really in the right place at the right time. I think Microsoft Research was one of the first places really investing a lot of effort in this data-driven conversation thing. And yeah, we were, when we first started out, we were using these noisy channel type models, but recently the neural network translation models have become more popular for both machine translation and in conversations.
And is that because the deep learning models are better at taking a lot of input? Or, I mean, I'm trying to understand, because like I said, right at 2010, you remember that's when everyone was like, oh, neural networks don't work. And then all of a sudden they really did because of the depth and
It's actually interesting. I think the
Yeah.
models that Alan built tended to produce more interesting responses, but they weren't very fluent. And with the advent of neural models, that same data dumped into the neural models
So it's
produces
smoothing
very,
almost.
yeah, exactly, very fluent responses that tend to be bland. The model tends to produce this very very dull, statistically safe response in every case. And a big challenge has been to try to goad it into saying something more
do
interesting.
like a Boltzmann, push it out of its state.
But it might also be that it's helping us to differentiate the how we talk from what we say, right?
Yes.
So there's two axes. It's
Yes.
how we say things. Is it English? Is it French? And what is it that we're saying? We're saying the same thing in these various languages, and so the neural models are really good at learning how we say things. And we're now working towards improving our ability to control what it says.
So, I mean, it feels like when you say what, I mean, it feels like you're trying to inject some kind of personality into it somehow. Is that
Right. So there's personality,
yeah.
there's grounding. So Bill's previous example was always, is the Starbucks open? Well, that depends on where you are. Are we in Seattle? What time is it?
I
The
see.
answer, it needs to be grounded, right? So that's the what it's going to say. How it's going to say that, yes, it is, or hey, there's only 10 minutes left till when it's open, that's the how we're saying things.
And it's worth saying that I think this grounding is critically important, as Bruce was saying, that it's really vital that we connect these conversations to the world, or it's just blather. I think traditionally in natural language processing, we tended to map from language into language, whether it's translation or summarization or spelling correction, like grammar correction, that kind of thing.
But I think even there are some sort of useful applications. Like if I get a text message, my friend says like I'm feeling sick, you can maybe predict how to respond to them without even seeing any input that they're typing in, right? And just sort of they can click confirm and send, to respond.
And
So I feel like we've talked about this a lot, and I want to see something now, and I want you to talk to it, Bill. Looks like you've got some on your computer here. Let's see. He's put his glasses down. It's gonna be good.
Yeah, let me just try an example. I can do the one that Lucy. Something kind of frequent, like I'm feeling really sick.
I'm feeling really sick today. Okay.
Which is really common. You're going to see that. Sorry, this is a little slow over the network, I think. There we go. Where this is not being retrieved from a corpus of responses. This is being made up by the neural model word by word. This is a very high frequency kind of exchange. Whoops.
And that's cool because like usually when I'm doing stuff with machine learning, like there's a specific task, but you just literally typed in, I'm feeling sick today. And to me, that's not input that I would give a computer, right? I mean, but it's cool that you've been able to actually model the typical responses for that kind of thing, right? Can you show us some more examples?
Yeah, so why don't I just show you something that, let's see, something like my mother is coming to visit. Actually, when I do it, I'm going to restart the context so it's not affected by the prior term.
So when you say it's not affected, does it keep like a stack of information?
In various experiments, we're taking advantage of prior context to influence what's said. So just to, I really just want to point out the pronoun here, that it's getting she. First of all, it's a well-formed sentence,
Yes,
and the pronoun
beautiful.
is right. If I say something like my father is, well, let's try that over here. My father is coming to visit.
So there's a deep model. I'm sorry.
So you see he,
Okay.
which again is a very low-level kind of experience to show, but it is really fascinating to me that it's getting the words right, it's doing the lexical choice very nicely, it's getting the word order right, it's getting the pronoun right, and
Yeah.
it's very good at this kind of pattern.
I mean, indirect object pronouns, when I was doing research, was the bane of NLP's existence, right?
And you would have imagined that you would have to write a rule.
Yeah.
Right? That you would imagine that we needed to do co-reference resolution and all of that. But it's just falling out from the model because the models, because they've been trained on such huge amounts of data, they've learned how to talk.
I see. So, what can this be used for? Like, because right now, to me, if someone's watching this that doesn't know about NLP and hasn't done research in this, and is not like completely blown away, because I am, what is this? What would this be used for?
Yeah, did you want to?
Yeah, I mean, I think like I sort of mentioned before, just like if you want to automatically generate replies to an email or a text message, you could sort of just, it could generate something and just click send if it's a common response. I think there's also a lot of opportunity to integrate this into more goal-directed dialogue systems.
Okay.
So it's more like natural, like talking, instead of like feeling like really talking to your phone, it's more like you're talking to a person and having a natural conversation.
I see. Bill?
No, I was going to say that I think this notion of grounding is really important, and that's where the leap to neural models from the older statistical models is really important, because in these neural models where everything's a vector, we can entangle linguistic information with real-world information. Features from a photo, something else in your environment, the state of your machine, all of that kind of thing can be entangled in this model that now knows something about both language and its intersection with your program state. So we can begin to now move away from this kind of chit-chat scenario. We're really not trying to build a chit-chat model here. We're, as Alan was saying, we're trying to build a model that is aware of your world around you, but also knows how to engage you in a turn-taking conversation. And its responses can be influenced, and potentially your responses can influence the state of the world.
Is there a
Right.
way? I'm sorry. Go ahead.
I was just going to say, and again, according, kind of if you follow the cooperative principle of conversations, you don't want a computer that robotically says, I am talking at this moment, we leave out a lot of information as well,
Right.
because maybe you've already told me that information. So we also want it to the how needs to be natural, and it will. If the more natural we can get the conversational agent to be, the more you're willing to interact with it and to share with a conversational agent information about you that will help it do its task later on.
I think we're coming at this from this perspective that we're not trying to build either a chit-chat engine or a purely transactional, task-oriented dialogue engine. We're trying to blend both into the same model.
So you're saying you could take this conversational model and blend it with, for example, your insurance company bot. And what it will do is you can start talking insurance to it, and so you get the model for insurance knowledge with this sort of smoothing model that's smoothing the real conversation.
If you think about renting a car at an airport, most of that conversation may be transactional, but there's likely to be some sort of polite sugar in there. The person behind the counter will say, oh, you're going to the Grand Canyon? The weather's beautiful out there today. Something like that. It's relevant to the conversation, but it's not relevant to deciding what car you're going to get or how many days you're going to have it. So we're aiming more for that combined model.
Well, this has been really awesome. Apparently we ran out of time. This is good stuff. I mean, it touches to the heart of some of the stuff that I got to work on. This is really impressive work. Thanks so much for spending some time with us. Thank you, Bill and Lucy, for your time and fascinating discussion. We look forward to hearing more about conversational agents in the future. Also, not forgetting the professor.